So I want to do a couple of problems for you from sections 5.1 and 5.2. So I'm on pages of the written exercises 2.13 and 2.14. This involves laws of exponents and essentially simplifying these expressions. So I just randomly grabbed number 15. So let's look at that. It's on page 213. We have u squared over v times, and in parentheses, 3v over u squared, all raised to the second. So I could have written this out before talking here, and but I wanted to go over this problem verbally, orally, so that you kind of get an indication of I think a little bit of what goes on in the order of operations. So what really we have here is this actually is all times that, but we don't often write this with these parentheses. Now this implies that we have numerator times numerator and denominator times denominator, with the exception of, in terms of one little additional complicating factor, we have this squared here. Now this is an explanation and a way that you can hopefully remember how to do this. Look, so if we have x squared and we write it this way, what this is saying, what this exponent is asking, is that whatever is inside here times itself twice. Now we also have exponents here, and one of the rules of exponents is that when we're multiplying with the same base, we add exponents. So this is equal to x to the 1 plus 1, which is of course equal to x to the 2, or x squared. Now consider this up here. Okay, so it's just a little more complex. Instead of just having x inside the parentheses, we have 3v over u squared. So I'm going to write this differently. Now listen, multiplication is great. Multiplication is in any order that you want to do it. So I can now rewrite this and say, look, in the numerator I have u squared, and I'm going to draw the bar here, and I have 3v squared, or 3v times itself twice. And in the denominator I have v, and I also have u squared times itself twice. Okay? Now, there is, with the laws of exponents, another way to think about this, and they're going to come up with the same answer, and that's why I'm doing this. So we can now say, okay, u squared all over v, but I deal with the exponents first. So this is 3v, so this is 3 squared times v squared. Again, the law of exponents is I'm going to multiply this outer exponent times the given exponent for 3 and v. The understood exponent for 3 and v is 1. 2 times 1 is 2, in each one of those. And this will be u to the 2 times 2 down here. So this simplified is now u squared over v times 9v squared all over u to the 4th. Now let's go back up here to this this top part here and see that we come up with the same thing. So we get u squared times 3v is u 9v squared all over v u to the 4th. And if we come back down here, we see that we will get exactly the same thing. We get u squared 9v squared all over vu to the fourth. And hopefully you'll see that yes, we do have the same thing. We're not quite done. This can be further simplified because we have a common factor here. Now again, this can be done in two ways. You can see that we have v over v squared. There is a common factor of v. We can also subtract exponents here. So the understood exponent for v is v to the 1. We subtract exponents, or we can see this as having a common multiple. In any event, we are left with u. There is no 9 here. 9v, because this goes into here once. And in the denominator, we're left with u to the fourth. So, and I know that looks like a 4, but that's a u. Now, it's common that we write the coefficient first, so we go 9uv all over u to the fourth. Well, we can notice that we have one of these here. So this can further simplify to 9v all over u to the third, which I'm hoping is the correct answer. Excuse me, you know what? I didn't carry over a 2 here. I'm looking at the answer here, so actually what I had here was 2u here, so actually the answer is u to the second here, 9v over u to the second. Sorry about that, but that's all right. You can see where I've made the mistake here. So that's that one. Let me get a clean board, and we'll do another one from section 5.1. Here is another problem, number 30, which is the next section on page 219. Now, the next section, 5.2, deals with negative exponents. So I went over in class with you how to derive this and how to think about it. Is 10 to the second, typically, we use 10 base 10 because of it's generally easier for us, is 100. 10 to the 1 is 10. And this is 10 times 10, of course, and this is 10 times itself, not times itself. And then we get, if we keep going in this pattern of decreasing the exponent, we can easily go from 10 to the 2 to 10 to the 1, 10 to the 1, and immediately go, all right, 10 to the 0. And then what about 10 to the negative 1? So the immediate and easiest way to think of this is a number line. And say, look, we have 0 here, and let's put 1 way over here. So when we are increasing exponents, we are making larger and larger numbers. And that's what an exponent does. It allows us to express numbers both large and small by using an exponent. Now, let's tackle 10 to the 0. Let's say we have 10 to the 5th over 10 to the 5th, and we're trying to figure out what that is. Well, we know that any quantity over itself is 1, but we also know from the law of exponents that this is equal to 10 to the 5th, subtract the exponents, and this is 10 to the 0. So very quickly, we have proven that anything to the 0 power is in fact 1. So that's easy to do. So this is 10 to the 0, which is 1. Now, think of the next step in this way intellectually. Negative exponents don't create negative numbers. If we did that, we would have a coefficient in front of the term. I'm not going to write it there because I don't want to be confusing. Negative exponents make numbers that are between 0 and 1. They're small numbers. We're getting small. And what this does is that when you see a negative exponent, it goes to the denominator. So this becomes 1 over 10, which is 0.1. I'm crowding myself here. 1 to the minus 2 is 1 over 10 to the 2, which is 0.01. And if, again, we look at our number line here, we're creating small numbers. Numbers between 0 and 1, not negative numbers. Okay, so that's by virtue of a little bit explanation of 0 and negative numbers in exponents. So let's work on this this problem here. It's number 30, page 219. Listen, the best method here is to distribute this exponent here. We do it by multiplying. So this becomes, and again, 5t is not part of this parenthesis. So we go s to the negative 1 times the negative 2 is s to the positive 2. T to the negative 2 times negative 2 is t to the positive 4. And now we get to distribute, oh, I lost my pen here. Now we get to distribute this number across here. My brush size got way too big. And distribute it here. So we get 5s t to the 1 plus 4 is 5. So our end here is 5s I'm sorry, s squared, there we go, t to the 5th. Sorry, that was a little confusing. We have 5s squared t to the 5th.